Alright, so here we have the final build and implementation of the Centipede game. As you can see here, we've got a fully working tractor mode with an AI player bouncing around the bottom there, constantly firing. We've got a Centipede moving around on the screen. We've got the high score lists that are writable from this file right here. We've got a level system that's determined by this text file right here. As you'll be able to tell, the number of solo heads increases in every level, and the spider speed also changes per level. So as the player moves through here, we've got the spider moving around doing its thing with the diamond-shaped movement. We've got the centipede moving continuously down, interrupted only by the mushrooms. We've got the flea falling down on the screen, creating mushrooms as it goes. You'll saw there when it gets shot, it will fall faster and stop shooting or stop creating mushrooms. And then we've also got a scorpion that will come through and create mushroom tiles. I can show you that a bit later when I can use the console commands. As you've seen a couple times, we've got the player that will die and the mushrooms that will respawn, and then the player will respawn and the game can begin again. So if we enter into play mode right here, we've got ourselves some sound. I'll turn that off now so we don't drive ourselves insane. As you can see, the player reacts to keyboard commands now. You'll see up here in the HUD, the scores react to the what's actually going on in the game. The HUD also updates with the number of lives that the player has left. The number right here is the current high score of the game. That is obviously read in from the text file. So as you move through here, let's see if we can change up the level. As you can see, we've got 2 solo heads instead of just 1, and as the new spider spawns, it will be significantly faster than the previous one. Obviously, we've already seen the flea, but I can just spawn a couple more there real quick. Show you that they do fall in the straight line, producing the mushrooms as they go. I can also spawn a few scorpions here, and as the centipede hits a poisoned mushroom, it'll go all the way down to the bottom of the player area. And as you can see from this screen here, the centipedes don't move out of the player area. Once they're there, they're stuck in there. So once again, player dies, all the mushrooms are going to be regenerated, including the poison mushrooms, back to a regular state. The one real big issue remaining in the game is if you close the game out while the mushrooms are being regenerated, it will crash on you. That's an issue with the way I've got the mushroom regeneration set up. When an explosion is recycled, it triggers the next mushroom in the set to be regenerated, and that also triggers when the game is closed out. So as you see here, I've almost managed to get a top score, but not quite. So I can go ahead and enter my initials. I'll just enter YOU here and hit enter. And you'll see YOU there in the second place with my score. I believe that's all that we needed to show for that. Next up, I'll go over the class diagram and start getting into the code. Alright, here's the big class diagram as a whole. And I can zoom in here and give you a little introduction before I start going into the code. We'll start here with the critters and the implementation and features of the critters. Alright, here we have the scorpion class. We're going to start discussing with the scorpion and the flea because they're the simplest of the critters that I have to show. For example, the scorpion, constructor and initialize method for recycling from the factory. In the update here, it just moves along in the X direction, and if it collides with any mushroom, it will go ahead, check to see if there's check to make sure there's only one normal mushroom in the space. Change it to a poison mushroom here and continue on its way. This helper method here makes sure that only the mushroom in the correct spot is turned into a poison mushroom, not every time the scorpion collides it creates a new poison mushroom in the tile. For the factory, fairly simple. Like most of the critter factories, it's just a singleton factory with recycling. It also keeps a hold of the active items. So all the scorpions that are active on the screen will be in the list here, and that makes it much easier to destroy all of them when the time comes for that. Flea, very similar in implementation. Initialize method again for recycling. The update method here is moving down by the speed. In this case, instead of checking for a collision with a tile, it checks every tile to see if it should create a mushroom there. By random chance, it's percent chance out of 100. If the tile it's trying to create a mushroom in is an empty tile, then it will set it to be a mushroom. This avoids the flea from creating mushrooms on top of tiles such as the border tile or the player tile, things that are important for centipede movement, and also avoids creating mushrooms on top of HUD spaces. Again, the factory very similar to the scorpion factory. Singleton recycling factory keeps track of the active items in the scene at one time. Now for the spider is a little bit more complicated. The spider only moves in reaction to the spider controller in a strategy pattern. So here we have the movement methods that are triggered by the controller. The spider itself doesn't move in the update. It only checks for checks to make sure the spider is not off the screen already. If it is, then it will clean itself up. The spider also dies to bullets and checks the distance using the player's distance from method, and then based on that distance will create will tell the score manager to add the correct score, will tell the explosion factory to create the correct sprite image on the screen of how many points were scored, and display that there. The spider controller here in the update method uses enums and movement states to make sure that the spider is moving correctly when it tells the okay. So the spider movement methods take a target position. That position is created once it's reached. The spider controller asks to get the next move. So the switch case here creates the kind of angled pattern where it goes up, it goes down, and then it moves up and down a random number of times, here represented in up-down cycles. Once it's done with that, it moves on to the next one, and then obviously once it gets off the edge of the screen, it is destroyed and cleaned up. The spider factory here just creates spiders, not spider controllers. The spider controller creation code here uses the spider factor to create a spider. So the implementation in the game is to use the spider controller factory here to create a controller, and that controller will create a spider for the controller. Using that flow makes sure that when the spider is hit, the controller manages all the deletion codes so that there's no extra controllers off in the ether without any spiders to control. But much like the other critters, the spider controller factory is just a basic singleton recycling factory here. Again, an active items list, so everything is easily destroyed. For the Centipede, things get a little more complicated. The Centipede is divided up into segments and heads. The superclass of both of those is the Centipede part. So the Centipede part holds the common code between the two. Things like, you know, the update method or the movement methods here, collision methods for, actually just kidding, collision methods are in each individually, but methods that deal with the attaching of bodies back and forth and the data that is included in each one. The segments are relatively simple. This sets the sprite and the rotation correctly, an initialize method obviously for a recycling factory. The movement methods here simply, you know, move the position of the sprite onward. In the case of the turn down and turn up methods, using the rotations to smoothly rotate through the turns. I would like to point out, let's see, where is it? It's in the CPP. I did fix the odd math that we had going on earlier. That's the factory Centipede part. It's now 180 degrees divided by, this is 15, the tile width over speed. So this is essentially the number of steps that the centipede part has to go through when it's moving straight across a cell, and then 180 degrees divided by the number of steps is the number of degrees the part has to turn per step. So the segment has its movement methods here. It has the get shot method, which will call the handle centipede destroy. I'll get to that in a little bit. The head, a little more complicated than this segment, deals with the creation of the movement traffic cops and the checking of spaces forward. All of that is in the check forward method here. So goes through a switch case based on the grid pointer, or based on the grid square that's one square ahead of where the head is at the time check forward is called. If it needs to turn, it makes sure through this method that it is not locked into the player area, and make sure it doesn't turn down off the screen. Otherwise, it creates a forward cop here, and it also deals with the poison type here. If it is poisoned, obviously here it continues to turn down unless and until it reaches the bottom of the screen. Factories for the Centipede here. This is a little more complicated than the other critter factories in that it has to deal with the creation of heads separately from the creation of segments here. So it has separate active items. Does it have separate active items? No, it has one set of active items for both heads and bodies, but the heads and bodies recycled lists are separate in order to make sure everything is initialized correctly. As for the cops, as I said, they're created in the heads check forward method here through their cop factory right here. This is a recycling factory, even more complicated further than the Centipede factory. The cop factory has to check through an enum called cop type here what kind of cop that the client needs to create, and based on that type will create it, and if possible from the recycled list. The recycled cop here checks its own type before adding itself to a recycled list, and then obviously keeps track of all the active items and deletes them as necessary when the time comes for that. From there, I'll move on to the player and related classes here. So the player class here, we have a very simple update method, because obviously the player is the quintessential example of the strategy pattern. If you'll note here, has pointer to the player controller. Player controller has a pointer back to the player. Uses it to call the player's movement methods here. Move up, move down, move left, move right. Fire action here. This add bullet method creates a bullet on the player plus bullet offset. Obviously that bullet is going to be in follow mode to begin with. Only when it's set active through the fire command here is it going to shoot off towards the top of the screen. But I'll get to that in a little bit. Right now we just have the player, and it's so the main chunk of the code in the player class itself is going to be the collision methods. Here obviously when it collides with the mushroom tile, it gets clamped to the section of the screen not on top of the mushroom tile. That keeps the player from just moving straight through mushrooms. The collisions with the critters over here is informs the classes up the food chain that the player has been destroyed. Marks the controller for destroy, because obviously the controller owns the player, so when the player should be destroyed, the controller handles that sort of cleaning up process. That way the controllers aren't floating off in the ether if their player's been destroyed and cause issues. Another thing to note here is the distance from method is here in the player class. That's used in the obviously in checking to see how many points should be scored from a spider being destroyed. So on to the player controller. The player controller here is the basic keyboard controller. So checks for key presses and uses those key presses to send the correct methods through to the player. The destroy here marks the blaster for destroy and deletes the pointer that the player controller has. That takes care of cleaning up the player itself as well as the cleanup of the player controller object. The attract controller is a player controller that simply has an overridden update method with a very similar state of affairs to the spider class. The attractor controller uses enums to determine what messages to or what methods to call from the player itself. So move left, move right depending on the X state, move up, move down depending on the Y state, and then checks the position to determine when it should switch those states. The way I have it set up now is it just bounces around the player area, so it only switches a state anytime it hits a wall there. And as long as the player is intact, it's going to go ahead and try and fire a bullet. The bullets themselves are a little more different. Obviously, they too are controlled by controllers here. The attack controller sends the message for the bullet pointer to move on upward up the screen by bullet speed, and checks to see if the bullet is off the screen. If it is, cleans it up. The follow controller here just sets the bullet position always to the correct location on the blaster. So for the bullet itself, there's a few interesting things going on around here. Obviously, there's an observer pattern with the player, because the bullet needs to know and have access to the player's position. The player needs to have access to the bullet's methods. The player controller does, rather, needs to have access to the bullet's methods to effectively, fire the bullet, that sort of thing. So we have the constructor, the initialization. That's for the recycling bullet factory. We've got an update, which is only the essentially the controller update. And then the various collision methods. Here, when the bullet collides with a tile correctly, it will tell the tile to take damage, obviously shrink itself, and do all the necessary things there. Later on, I was able to create collision methods in the actual other methods themselves, so they will take care of the other classes will take care of destroying themselves when hit with the bullet. The bullet only has to deal with its own cleanup. So it will set itself inactive, which means a new bullet is going to be created through the bullet factory, and it marks itself for destroy. That this set inactive method here makes sure that none of the methods can be called on the bullet here while it's being cleaned up, and if its player is active, then it will create a new bullet there. That ensures that there is only one bullet on the screen at a time. because if a bullet is active, another one can't be created. Once the bullet is set active, it immediately creates a new one. The bullet factory here is, as per usual, a recycling factory. This one, I believe, is not a singleton because it's only used in this specific context here. After that, we're going to move on over to tiles and the tile field. Alright, the tile system for the game is based around the tile field. The tile field at its core is the 2D array of tile pointers, grid width by grid height, in this case 35 by 35. So tile is the superclass that has, I believe, 6 children, something like that, all of which are fairly simple. The main difference between all of them is the get type function here. Here, for example, the bottom tile is basically exactly the same as a tile. It just returns the type correctly. This is used for the centipede dealing with movement correctly. So the borders of the screen will let the centipede know that they're borders. The bottom of the screen lets the centipede know that it's the bottom. The top of the player area is notified as that. Other differences between the tile subclasses are the sprites. So for example, the mushroom tile here loads up the mushroom sprite as opposed to the poison tile. Obviously is going to be the poison side of the mushroom. And they naturally have their own update draw methods, slightly different, not very different. They also include take damage, so this is called when the bullet hits them. It calls other arrow take damage. That's this method here. The damage levels increased. If this destroys the mushroom entirely, then it's removed from the list of damaged mushrooms in the tile field. That's the list that's iterated through to regenerate all the mushrooms. So this avoids trying to access a null pointer trying to regenerate a mushroom. The score is added, and the mushroom is set inactive here, which tells the grid that, hey, this space needs to be unoccupied again. Sets the tile to not defined, deregisters collision, marks it for destroy. Otherwise, if the tile isn't supposed to be completely destroyed by this shot, it'll just increment or just add itself to the next frame, which is that eating away of the mushroom animation that you see in the game. So the tile field, as I said, is a collection of these tiles here. In the initialization of some of the structural code, we'll have a populate field that will randomly decide when mushrooms should be placed by inside percent inside the player area, outside percent outside the player area. For testing, I've got all of the inside the player area completely sealed off, or completely uncluttered with mushrooms, so that we get the flea falling right away. And then obviously we have this set tile method that is called when the state of a specific grid square should be changed. This is used with the enum tile type. When you want to switch to a certain type of the tile, switch case here, we'll set the specific grid position at X value, Y value to whatever type you're looking for. In the case that you are creating a new mushroom inside the player area. That specific number here is incremented. That is access to determine when the flea should spawn, rather than having to iterate through the grid constantly. This type add method is similar. It just checks what target type or what type is at that specific grid element that you wanted. It also has the modification methods here, taking a screen position and giving the grid coordinates, or taking the grid coordinates and giving back the screen position. It also manages regeneration of the mushrooms. So this is called through a bunch of the structural code. This is the final level. It checks to see which mushroom should be regenerated next, calls its function, then breaks out. Obviously, once it's called again, it will have iterated through to the next mushroom in the list. By the time the mushroom iterator gets all the way through the end of the list, it will reset damage lists, changes the iterator back to the front of the list, and the game manager will respawn the player, because this regen method only is called once the player has actually died. Here, add remove from the damage list and reset the iterator, obviously, right here. Then from there, we're going to move back over to the explosions here. The explosion base class here is just a real basic visible game object. It's expanded on by its subclasses here. The cycle explosion, which is an explosion that disappears after it has run through its animation one time. Obviously here, his last animation frame marks it for destroy. In contrast, the timer explosion here takes a time it's supposed to be active, sets an alarm, only destroys when that time is up. It doesn't actually animate through. The explosion factory here, a singleton recycling factory for both cycle and timer explosions. Create a player death explosion is the specific type of cycle explosion. Mushroom regen, another specific type of cycle explosion. As you'll see here, I've saved the animated sprite and associated methods here. So when I want a specific type of cycle explosion, I only have to call the method. I don't have to run through different codes. I don't have to create essentially two of the same class just to have a different animated sprite in there. And then by contrast, we have the timer explosion with, as you can see, the three different sprites here. Timer explosion created here using enum value to determine which exact sprite needs to be placed in there. And then, yes, so recycling factory, fairly simple, other than the animated sprite being added in the factory rather than in the class itself. And then let's move on here to some of the more structural coding here. We're going to have the text reader and the sound manager. So the sound manager, like it says on the tin, a singleton manager that deals with the audio, the sounds playing in the game. This is actually another strategy pattern here for the sound off and sound on. As you'll see here, when you call the static methods of the sound manager to play a sound, start or stop one of the looped sounds, it goes through the manager directly onto the states method. So the state loads up all of the various resources, the actual sound files themselves, and then in the subclasses here we have defined the start and end methods for each of the sounds here. So with sound active, obviously you start, pause the sound loops, or play the correct single shot sounds. If sound is inactive, then obviously you default to the regular sound state here, which has nothing in those methods. Another smaller piece of the structural code is the text reader here. Text reader is a little bit more complicated than the sound manager in that it has to deal with file reading, file writing. But it is just a singleton that reads the files in at the beginning of the game using the private methods here. Read waves file reads in the data from the waves, checking to see which data point that specific number should go to, adds it to the structure here that I've set up of the structures in the .h. So the struct here of the different values associated with a wave. In the reading code here, it determines which values should go in which slots, puts the numbers in, and saves it to the vector of data for each wave. So obviously wave number 1 is going to be vector index 0, so on and so forth. So that method only happens once at the beginning of the game. From then on, the data can be read in by anyone that wants them by getting the waves data here, which will return that struct of whichever level they were talking about. Similarly, the read scores file can read in the top scores either as strings or only get the numbers here for the integers. This is useful for comparing the player's score to the top scores later. You need to have access to them both as a string for writing and as integers for comparing. The text reader also deals with writing of high scores here. When a new high score is reached, it'll determine the specific line in which that score should go and print it out onto the file. And then obviously the bonus score stays the same no matter what the high scores the player gets, so that is just saved from when it was read in at the beginning and printed out again at the bottom of the file. Alright, moving on, we're going to talk a little bit about the HUD and the sprite sheets here. The HUD is based around the flyweight system, which doesn't have many significant changes from the demo. Obviously, the glyphs are created in here using the get glyph of whatever value is necessary, put into the specific place. The list of symbols is drawn every update, and then obviously the baseline of the flyweight is exactly the same. Just using glyph to draw from a sprite sheet, which keeps the processing to a lower degree than having to compute the subrectangle of texture every time you want to create a new number on the screen. The player's scored 1 point and you need to change something there. On to the HUD itself. So basic HUD is going to be owned by the score manager. so only needs to update when a new score is added in. So update current score here, takes the new score, chops it up into the specific places each one is in, and creates a glyph in that spot, adds it to symbols list here. Same thing happens for updating the high score if and when that is necessary. The basic HUD also deals with setting the lives of the player. The visual representation up in the top left is created with dummy players that are that look the same as the blaster. They just don't have any of the code overhead or movement or action methods that the player itself does. And the HUD here removes lives, adds lives, sets the number of lives here. That's going to be called through a bunch of the structural code that I'll describe later. The attractor HUD and the high score HUD are also different types of more specialized HUDs. The attractor HUD here is only for in the attractor mode. It creates the player score creates the player score at 0 just like a fake regular HUD, but it won't change through the attractor scene. Sets up the top score just like the regular, and then sets up the lines of high scores, the list that it's loaded in from the text reader here. Text reader loads in the score lines and the top scores, and it will print them out here using the glyphs. Sets up the ending text here using a read in from the text reader bonus score here, so obviously changeable based on whatever the designer decides there, and the draw method, obviously nothing different. For the high score HUD, this is going to be a little bit different than the attractor HUD in that it takes in the text entered by the player. So if the backspace is hit, then it obviously pops from the backs of the symbol list, gets rid of the glyph at the end until up to and until the player deletes all their letters. Obviously, you can't delete any more than you've already typed in. If the player hits enter, any extra spaces are filled in using the Octothorpe character there. That's to keep the spacing intact. If I were to just put an extra space character there, it gets shaved off when the text file is read in. So an Octothorpe preserves the spacing. Even if you only enter one letter or no letters for your initials, your score will still be in line with 3-letter initials. And then it directs the text reader to reread or to write to the high scores, and then directs the manager to reread the file through there because it's been updated and changed. Obviously draw, not any different than the rest of the HUDs. Then we'll talk about the score manager, the wave manager. Down over here is the wave manager. Getting a little more up the food chain from the previous discussions. Now we have the score manager here, which owns the HUD, as you can see here. My HUD is created in the initialization, destroyed in the destroy here, marked for destroy at least. Score Manager is a singleton accessed through a lot of different places, but all directed through the score manager here. In the different collision methods in the critters, they'll call the score manager to add the correct score here. These score constants are set in the .h file here, so available for editing if and when the designer needs to. And they call the private add score method, which adds it to the current score, adds it to the counter that determines when the player has earned a bonus life, and this method also directs the HUD to update correctly, as I showed in the earlier clip. Updating the current score will create the glyphs necessary for the screen to represent what the actual player's score is. And here are a couple of load methods for example, the top score displayed at the top of the HUD. Also useful. Loading in the top scores helps to determine when the player is earned a top score, and so the high score HUD needs to be displayed and added to the scene. Wave Manager is kind of the super factory, consolidates a lot of the other factories together, uses one simple method to create everything that needs created. Wave Manager also keeps track of the number of Centipede parts remaining, so it can tell the game manager when the level has finished. So obviously, create a Centipede here takes in the number of segments, creates them through the Centipede factory. The same for the solo head. Wave Manager update is these are just the debug keys, so I can show off all of the fancy coding work I've done this quarter. Create scorpion, flea, spider. Very simple methods because all of the more complex stuff is dealt with in the lower levels of code. And then here, delete all the critters, made simple by the active items list in all of the factories. Can just clear them all out right away. Wave Manager also deals with the creation of players and AI, the creation of keyboard and AI players, which is done, right here. The pointers are kept to that so that they can be properly cleaned up, deleted, everything through the game creation loop. And finally, we're going to get into some of the higher level structural coding, the game manager, and the levels. So this is the top level of the game code here, the level files. This will be where all the collisions are put together, and the game manager initialized in the main level, obviously initialized for regular gameplay, the attractor level initialized for the attractor mode. There's also the attractor manager created. That is just a real simple manager designed to determine when the key's been pressed to start the real game. Change the scene to the main level. The game manager is where all the action is at. As you can see, the game manager is kind of the puppet master of the game, the overall director that tells everyone where to be and what to do at what times. So the initialization here for regular game loads in the player data, initializes all the player data, initializes the sound manager, initializes the grid, reads in the information from the text reader, and sets everything up, starts wave number 1, creates a keyboard player, sets up the score manager, and sets the correct lives, ignoring the attractor mode stuff for now. Setting up a level involves obviously creating the centipede, setting all of the management booleans for the critters correctly, and setting the ability to setting up this the new high score variable here. Makes it so only during a regular gameplay can the player earn a high score. We can't do any high score foolishness during the attractor mode. So during the update here, it checks to see whether various critters should be spawned, that sort of thing. Obviously, the game manager is a singleton, so its methods can get called from anywhere. So things like, let's see, the player destroyed method here, called when obviously the player is destroyed, can activate the sounds correctly, can deal with the number of lives and the HUD updating, deals with directs the wave manager to delete all the critters, sets the various booleans as they should be, resets the grid iterator, and then lets the loop of the mushroom regeneration go to town. As you might have saw earlier, once that mushroom regeneration is finished, it goes back up here to the respawn player here. This respawn player is called not only when the player has the respawn player method is called when the player has been killed. If the player is still able to play through, then only the level will have to be reset, started again. Easy enough. If the player has run out of lives and has accumulated enough points in order to make a high score, the high score HUD is created and allowed to run its course. If not, then the game manager directs all the proper assets out of the way, and sets the game back to the attractor mode. Obviously the setup for the attractor mode is a little bit different. The sound manager starts deactivated. The player created as an AI player rather than a keyboard player, and the attractor HUD is set up rather than the straight-on regular HUD. So the game manager itself doesn't do a whole lot. Obviously, during the destroy method, the instance has to be set to a null pointer so that switching back and forth between the levels can be done smoothly. Everything will be reset as normal when the game manager is called again. Yeah, so the game manager doesn't do or create a lot on its own. It's the overall director of the game and sets the various events in motion. And that's about all there is to it. That's what's taken up a lot of my free time over the last quarter.